Extracting metals low in the activity series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar (HgS) is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide HgO. Mercuric oxide is then reduced to mercury on further heating. 2HgS plus 3O2 in the presence of heat gives 2HgO plus 2SO2. 2HgO in the presence of heat gives 2Hg plus O2. Similarly, copper, which is found as Cu2S in nature, can be obtained from its ore by just heating in air. 2 Cu2S plus 3O2 in the presence of heat gives 2 Cu2O plus 2SO2. 2 Cu2O plus Cu2S in the presence of heat gives 6 Cu plus SO2. Extracting metals in the middle of the activity series. The metals in the middle of the activity series, such as iron, zinc, lead, copper, etc., are moderately reactive. These are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. The chemical reaction that takes place during roasting and calcination of zinc ores can be shown as follows. Roasting. 2ZnS plus 3O2 in the presence of heat gives 2ZnO plus 2SO2. Calcination. ZnCO3 in the presence of heat gives ZnO plus CO2. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it is reduced to metallic zinc. ZnO plus C gives Zn plus CO. Obtaining metals from their compounds is also a reduction process. Besides using carbon to reduce metal oxides to metal, sometimes displacement reactions can also be used. The highly reactive metals such as sodium, calcium, aluminum, etc. are used as reducing agents because they can displace metals of lower reactivity from their compounds. For example, when manganese dioxide is heated with aluminum powder, the following reaction takes place. 3MnO2 plus 4Al gives 3Mn plus 2Al2O3 plus heat. These displacement reactions are highly exothermic. The amount of heat evolved is so large that the metals are produced in the molten state. In fact, the reaction of iron oxide Fe2O3 with aluminum is used to join railway tracks or cracked machine parts. This reaction is known as the Thermit reaction. Fe2O3 plus 2Al gives 2Fe plus Al2O3 plus heat. Extracting metals towards the top of the activity series. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminum, etc. to the respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode is at the negatively charged electrode, whereas chlorine is liberated at the anode, the positively charged electrode. The reactions are: at cathode, Na plus E minus gives Na. At anode, 2Cl minus gives Cl2 plus 2E minus. Similarly, aluminum is obtained by the electrolytic reduction of aluminum oxide.